The next topic is, as you can see on the screen, couple. So this has something to do with moment and resultant of parallel forces. Wait lang. Okay, sorry. Continuing. So couple. Sometimes a resultant force system will be zero in magnitude and yet have a resultant moment sum. This system is said to consist of a couple. So that means even though the resultant is zero, meaning there's no lateral movement, it's still experiencing rotational movement. And that is because of a couple. So a couple is made up of two equal parallel oppositely directed forces, as you can see in the image. Okay, so FF equal, oppositely directed to each other, and parallel, of course. Then we have what we call your moment arm, similar to the term we had for moment. It's the perpendicular distance between the action lines of the forces. So that's this D. Therefore, the equation for couple, same with moment, it's force times distance. But instead of being the distance from a moment center, it's the distance between your two parallel and equal forces. So because of that, couple is independent of the moment center. Thus, the effect is unchanged in the following conditions. First, couple is rotated through any angle in its plane. Next, the couple is shifted to any other position in its plane. And then next, the couple is shifted to a parallel plane. Let me illustrate all of that. So let's say we have this system, right? We have a beam, we have a support. So let's say we have forces here. This is your F1. This is F2. And we had a couple. So a couple, the symbol for a couple is either denoted by two parallel forces or it's denoted by this. So C. Okay? So according to what was stated earlier, so let's say, let's draw this instead. So let's say this is our couple. Okay? Now, no matter how you rotate this, so let's say we rotate it this way now, its effect should be the same. So F1, F2, and then instead of that way, let's say I rotated it, became this way. Okay, once again, equal forces, F and F. the effect of this and this is the same. Okay, no matter how much it is, the forces are rotated. Okay, so that's one principle. Next, couple is shifted to any other position in its plane. So once again, let's take this as an example. Any position in its plane. So let's have this again. We're still on a single plane. So F1, F2. Shifting in its plane meaning you're going to change its position. So instead of being at the end, I'm going to put it here. Once again, even though I change its location, its effect on the system is still the same. Okay. And then lastly, couple is shifted to a parallel plane. So to show a parallel plane, let's have a cube as our system. Okay. Yeah. Right. So let's say originally the couple was located here, right? And so F. This is equal, or this effect of your couple is equal even if you place it on another plane. Let's say okay. So let's say I placed it here instead on the back. So these two effects are the same. Okay, so that's the concept of your couple. Any questions for couple so far? Please answer in the chat. Okay, since you don't have any more questions, let's move on to the next. So let's have a few examples to further understand the concept of couple. Okay, let's start number 1. Determine the resultant moment about point A of the system of forces shown in the figure. Each square is 1 feet on a side. So basically, we're just looking for resultant moment. Not resultant of forces, resultant moment. So summation of moment about point A. Okay, so as usual, the first question I'll just answer it on my own. I won't ask you for recitation. But you can still answer, or you can still solve this on your own and just compare if you got the correct answer. Okay. So a moment at A is just summation of forces times distance. So let's see. Let's start at A. We're taking a moment at A. Let's take this force first. So we have again a matrix, right? We're given diagonal forces. So meaning I need to get its slope, because if I extend this line of action, once again, its perpendicular distance is a bit more tedious to solve. So I'm going to use Pyrenon's theorem. Okay, so let's get the slope of each diagonal force. Let's start here at the 100-pound force again. So to get the slope, you're just going to count how many boxes it takes to create a right triangle. As you can see, we have this. So that's 1 box or 1 unit for the base and then 2 units for the height. So this is 1, this is 2. Getting the hypotenuse, you'll get square root of 5. Let's do it here as well. Okay, so draw your right triangle. So we have 2 units for the height, 3 units for the base. So 3 and 2. Then once again, computing for its hypotenuse, that's square root of 13. Okay. Next step is to figure out where to place your components. Okay. As you may have noticed, I'm gonna put my components here because this vertical component will pass through A. Now, before, what we did was we solve for the horizontal and vertical components separately, but now we can just include it all in our equation. Okay. You may do this if you're used to getting the components already. So once again, y component, ignoring that, we're left with the x component. Rotate that about 8. That's counterclockwise, therefore negative. Get the horizontal component, so that's just copying the force multiplied by the horizontal side, so that's 1 over hypotenuse square root of 5. That's the horizontal component. Next step is to multiply it by its perpendicular distance, which is equal to this. So that's 1, 2, 3, 4 units. And each side is equal to 1 feet, so that's 4 feet. So that's pounds times foot. Let's do the same for the rest. This 200-pound force. Once again, I'm going to place it at a convenient side, if any, or convenient point, if any. As you can see, there isn't really a convenient point, right? Because all of them won't pass through point A. So instead of doing that, let's just put it anywhere. So let's say I'll put it here. So let's start with the horizontal side again, or horizontal component. Rotate it about 8. That's clockwise, therefore positive 200. Get the horizontal side, so times horizontal side times 3 over hypotenuse square root of 13. Next, the vertical component, rotate about 8. That's clockwise again, so plus 2 up. Sorry, forgot the distance. Don't forget the distance for a moment. Okay, distance of the horizontal side, so extend that. That distance is equal to 3 times 3. Okay. Next, once again, vertical side, rotate. That's clockwise, so positive 200. Get the vertical component, so times the vertical side, 2 over hypotenuse square root of 13 times distance. Distance of this is equal to this, so 2 units, so times 2. Okay, so we have the diagonal forces done. Now what's going to happen here? Now, if you have noticed, this 80-pound force has another partner, which is another 80-pound force downward. And remember, couple is composed of 2 parallel forces equal in magnitude but opposite in direction. So therefore, this is a couple. So to take a couple into consideration, what you're gonna do is we're gonna see its direction. So whether it's clockwise or counterclockwise. So to know that, you're just gonna follow its arrows, right? So up, down, up, down, up, down. So that's clockwise. So therefore, this is positive. Then recall the equation for a couple. That's just force times distance. The force is 80. Distance between them is 2. So times 2. Okay. Next, observe the next pair of forces. We have this 100-pound force. They're parallel but opposite in direction. Therefore, we have another couple. Check its direction. So to the left, right, left, right. So this is counterclockwise. That's negative force times distance between them. So the distance between them isn't that obvious. Okay. It's this, right? However, as you can see, that's actually the hypotenuse of this right triangle with sides 1 and 1. Okay, so 1, 1. Therefore, this hypotenuse is square root of 2. Okay, so therefore, distance between them is square root of 2. So times square root of 2. Okay, so you're just gonna take the summation of all of that, and you should get 560.80. Then unit, pound, each square or each side is equal to feet or 1 foot. So unit is pound foot. Okay. It's positive, therefore it's clockwise. So you can know clockwise, or you can write the word clockwise. Okay, so that's number 1. Any questions for number 1? Please answer in the chat. Okay, great. Let's move on to number 2. So number 2, the 3-step pulley shown in the figure is subjected to the given couples. Compute the value of the resultant couple. Also determine the forces acting at the rim of the middle pulley that are required to balance the given system. Let's focus on the first question. Compute the value of the resultant couple. Okay, so that's easy enough. Okay, so we're given this pulley system and it's only made up of couples. Okay, there's no vertical force or anything like that. Therefore, to get the resultant couple, that's just the summation of forces times distance. So C equals, so let's start with the innermost couple, right? This 60-pound force. Check its direction. So rotate, that's counterclockwise, right? Downwards to the left. So therefore, that's negative 60. Then distance between them is given 8 inches. So times 8. Next, on the blue rim, so follow the direction. So that's clockwise, right? So positive. Force is 30. Distance between them is 12. So times 12. And then last, we have this green rim. So rotate. That's counterclockwise, right? So negative. That force is 40. And then distance between them given 16. So times 16. Please compute what's the answer. Correct, it's negative 760. Correct, Gian and Michelle. So gustos yan. So negative 760. Unit, so our force is pound, our distance is feet, sorry, this is inches. So pound, inches. Inch. That's correct. Michelle. Okay, so first part is done. What's the second part? Determine the forces acting at the rim of the middle pulley, so meaning that blue rim, required to balance the given system. So when we say balancing the system, that means putting it into equilibrium. To put it into equilibrium, meaning summation of forces, summation of moment, and everything is equal to 0. So once again, to put things into equilibrium, that means resultant is equal to 0. Okay, summation of forces equals 0. We're given couple. So that's couple plus FD equals 0. Okay, this couple is your resultant couple, which is negative 760. And we need the force multiplied the distance between them to balance that out. Okay, so plus, because our resultant couple is counterclockwise, so we need a clockwise couple to balance that out or to put that to 0. Okay, so plus, we're looking for this force. And distance between them is given since, again, it's specified that it's going to be placed at this middle pulley. Distance is 12, so F times 12 equals 0. Please solve what's F. Correct, it's 63.33. Correct, Simon and Lloyd, Sosa and Chero. Okay. 63.33. And once again, our unit is pounds. All right. That's number 2. Next, let's solve for number 3. So number 3, a vertical force P at A and another vertical force F at D in the figure produce a resultant of 100 pound down at B and a counterclockwise force, a counterclockwise couple C of 200 pound foot. Find the magnitude and direction of the forces P and F. So basically, this figure is the resultant of a system of forces. That system of forces is a force P at A and F at B. So we need to know P, the magnitude of P and F, as well as its direction. Okay, so let's draw, once again, this is the resultant version. So let's draw the system of forces, right? This is point B, this is point A, this is 4 feet, and then 3 feet, and then this is point B. Okay, so first step, we're gonna assume directions of your given of your forces, your P and F, right? Since it's not given, we have to guess. So again, this is just guessing. You can make an intelligent guess since the couple is given. But in case you don't want to, that's fine as well. So I'm gonna guess, by the way, it's given that it's at point A and B. I'm gonna guess P is upward and then F is downward. Okay? So this system of forces creates this couple. That's basically it. And we need to know what's P and F. So to do that, one of the first things we're gonna do is, once again, use your equations. Now, if we use summation of forces, I'm gonna have two unknowns. So I can't solve for anything. So we can't use that. So therefore, I should use moment. Okay? And I'm gonna take moment about B because F directly passes through B, meaning that's gonna cancel out. So the only unknown left is P. Right, so let's do that. Moment at B equals RD. Okay. So let's use P first. Rotate P about B. Counterclockwise. So negative. Oh, sorry, that's clockwise. So that's P times distance 3 feet. Okay, that's all the forces for this system equals your resultant. This is the resultant. Rotate that about B counterclockwise. So therefore negative 100. Distance is 4 plus 3, 7. Right? And what about this couple? So this couple is a resultant as well. So therefore, you're just gonna know its direction. So it's drawn this way. Therefore, that means that's counterclockwise. So that's another negative. And just copy the value since couple is already given. So negative 200. From this, please solve for P. What's the answer? Negative 300. Correct. Negative, therefore, I had an incorrect assumption. So correct, Zaira and Eman. For this. Oh, 2 points ka na. Centones. And then who else? Negative. Andrew, correct. Kailan? Negative 300. So negative 300. Once again, that means an incorrect assumption. I assumed it's upward. That's incorrect. Therefore, it's 300. Unit is pounds. And it's downward. Okay. And then from that, we can finally solve for F, wherein R is just summation of forces. R is given negative 100 since downward equals. We already know P is downward. So that's negative 300 again. And then I assumed F is downward, so minus F. Please solve. What's the answer for F? Correct, JM and Andrew, Kailan and Illustre. It's negative 200. So negative 200 pounds. Negative, therefore, incorrect assumption. So therefore, it should be 20 pounds. I assumed it's downward. So that's incorrect. It should be upward. Yeah. So that's our answers. Okay. Any questions for numbers 1, 2, and 3? Please answer in the chat. Sorry, that's a typo. Thank you, Michelle. That's 200. Negative 200. 200. Wow. Okay. Okay. Number 2. 63 point, okay. 63.33. Yep. Okay. Thank you for the corrections. Okay. So no more questions. I'm gonna move on to the next problem. Number 4. Number 4 is easy. I'll show you why in a sec. Okay. Number 4. So a short compression member carries an eccentric load P equals 200 pounds situated 2 inches from the axis of the member, as shown in the figure. In strength of materials, it is learned that the internal stresses are determined from the equivalent axial load and couple into which P may be resolved. So determine the equivalent axial load and coupled. So basically, okay, this force P, okay, acting not at the center, meaning it's an eccentric load, not an axial load, will create stresses, specifically axial stress and then torsional stress. Now, to solve for that, I need to resolve this into an axial load and into a couple. Okay? So this will become and this. Okay? So I'm gonna put that here. And then the direction of the couple will follow. This is our point of interest. So that's clockwise. So our couple will be clockwise as well. Okay? So that's your C. And then this is your P. Right? Or rather, we'll call it R. Since it's resolving force P into components, axial and coupled, as you can see here. And equivalent axial load and coupled. So to solve for the axial load, which we written as R is actually just the summation of your vertical forces or your parallel forces. And there's only one. Therefore, R is equal to 200 pounds. Okay? Now, what about the couple? So the couple is just equal to your force P, rather force R, right? Which is again 200 multiplied by the distance it traveled. So 200, original point here, move to here. This is the distance it traveled, so that's 2 inches. So 200 times 2, you get 400. And then unit pound foot. Okay? Sorry, pound inch. This is inches. So pound inch. Okay, so that's basically it. That's how you resolve a single force into an actual load and its coupled. So that's number 4. Lastly, let's solve number 5. So number 5, replace the system of forces acting on the frame in the figure by a resultant R at A and a couple acting horizontally through B and C. So this is another resolution. We have the system of forces. I want to resolve it into a single force R at A and then a couple at B and C. So the steps are the same, we're just added forces. So R, once again, is just summation of forces. Now we have more than one. Okay. So by the way, I'm going to solve for this since we're almost out of time. So please just listen. Summation of forces. Let's start here. It's downward, therefore negative. So we have negative 20. Upward, therefore positive 30. Negative 60. Therefore, resultant is 50, negative 50. This negative denotes sign. Therefore, that's 50. Unit is kilonewton downward. Okay? So that's R. Now, the next, I need to get couple. So remember, couple, or a resolution to a couple, is just R multiplied by the distance it moved. Now, originally, R is somewhere here. Okay? But the question said it wants to be placed here. Okay, so this is where your R is. And usually, or typically, if we know this distance D, we'll know the value of your couple, but we don't know that. So instead of doing that, okay, and that's your supposedly distance of R, or position of R. Once again, instead of doing that, since again we don't know distance, what we're gonna do to get couple is just instead of R multiplied by D, it's 20, or it's the single forces multiplied by their distance to A. Since that is where you're taking the reference point, right? Since RD, that's R multiplied by B, distance from A, that's just moment at point A, right? So couple, the resulting couple is just moment about A. So once again, this is C, should equal to FD, but we don't know D, so that's just moment at A. Let's begin. 20, rotate about A, counterclockwise, so negative 20 times distance 1. 30 passes through A, so ignoring that. Next, 60, rotate, that's clockwise, so positive 60. Distance is 4. Right? Computing for this, we get 220. Positive, therefore it's clockwise. Now, are we looking for moment or are we looking for forces? Let's see. Couple acting horizontally through A and C. So this is the couple acting horizontally through A and C. Now, another way or to know exactly the forces that we need, remember, it's acting through B and C. So this is where your forces will act to create your couple. So it's clockwise, therefore our direction should copy that. Let's say it's like this. Okay? And this is clockwise, right? Therefore C equals FD. Okay? So that's 220 equals F. And then distance between your forces is 2. Therefore, F is just 110 kilonewton. So that's your other answer. Now, let's redraw our system into what's being asked. So we have a resultant here, R, which is equal to 50 kilonewtons. And then we have another force here. This is F, which is equal to 110 kilonewton. Should be acting clockwise. And that is how you resolve a system of forces into resultant and couple. Any questions for numbers 4 and 5? Please answer in the chat. How about the others? Please answer as well. Okay, great. So that ends our topic for couple. That also ends our discussion for today. Next meeting, Thursday, is your It's just a continuation of lecture, and then on Saturday we'll have quiz number 1. I'll explain quiz number 1 on Thursday as well. Okay. Once again, Thursday we have your continuation of lecture. We should be done with resultant by then, and then Saturday quiz. Since you don't have any more questions, I'll dismiss you now. You may go. Goodbye, class.
Thank you po, ma'am.
Thank you po.
Thank you po.